Walaikum assalam.
So my question is based on the uncertainty principle we talked about. When we do measurements, there will be disturbances. So why can't we say the uncertainty that has been caused due to these disturbances?
All right, that is really a very good question, I'd say. In fact, that was the original interpretation given to the idea by Niels Bohr. So, Werner Heisenberg figured out the uncertainty principle from the equations of quantum mechanics, and then when he told about this to Niels Bohr, Bohr suggested this interpretation that when you're trying to measure the electron, you're hitting it with something, maybe a photon, maybe another electron. So perhaps because the electrons are so delicate, you're hitting them with something that has to essentially change its energy or momentum or position. The thing is that the equations of quantum mechanics predict this uncertainty. So it is that it's not that you're basically taking into account that you're hitting it with something when you're writing the equations, and yet the equations will tell you that the particle has to be such and such. In fact, this thing called wave function that I talked about, the wave function encodes all the information about the particle. So if it encodes all the information about the particle, it can tell you what the possible values of the measurements of position or momentum could be. And when you write the equations and solve the equations, you figure out when you condense the possible measurements of position, that is, there are only so and so many fewer positions possible when you measure it, then the number of momentum, the extent to which momentum varies, enlarges. So lesser uncertainty in position means a larger uncertainty in momentum. And you solve the same equations and you figure that as you try to lessen the uncertainty in momentum, the uncertainty in position decreases. And we solve all these equations without taking into account that there is disturbance due to it